All right, so on this next page, we're gonna start by using the same verbal description that was given, and then we're gonna go from there. So it says that it has a negative leading coefficient that's degree 4. If I hear negative leading and it's degree 4, I know my end behavior is going down in both sides. All right, so I'm thinking it's going down this way, and I'm thinking that it's going down this way. The next thing I'm gonna go is I'm gonna plot all my zeros and all the points that I'm given. So I have a 0 at 2, I have a 0 at 3, I have a 0 at 0, and I go through the point 1, -1, which is right there. Now I'm going to use the multiplicities to help me. So at 0, I have a multiplicity of 2. That's going to be that bounce. So I'm going to start here. I'm going to come up towards 0, and I'm going to bounce. Now, when I bounce, I have to go through this point, and then I need to get back up to 2. So I'm going to come down, I'm going to bounce, and then I'm going to bring it back up towards that 0. So now at the next 2, I have a multiplicity of 1, which means I'm going straight through. So I'm going to come, go straight through, work back, straight through, and that's how you're going to get that graph that looks like that. It follows the end behavior, it hits all the zeros, it goes through your points. That's what it's going to look like. All right, next one is rational root theorem. So remember again, you're always going to try to factor if you can. If you can factor, awesome. If you can't factor, then that's okay too. This one you probably could factor, but we're going to use rational root theorem for this one. So rational root theorem says all the factors of your constant over all the factors of your leading. So P over Q is going to be equal to 8, 1, 2, and 4. Those are all the factors of 8 over all your factors of 5, 1, and 5. So all of your possible, you need to take all the combinations. So it's going to be plus or minus 8, plus or minus 1, plus or minus 2, plus or minus 4. Then plus or minus 8 over 5, plus or minus 1 over 5, plus or minus 2 over 5, and then I'm going to run out of room, plus or minus 4 out of 5. Those are all your possible. So if that's the question, like if it asks you what are all the possible, these are all your possible. It might ask you how many possible. So if I were to count how many, 1, 2, 3, 4, 5, 6, 7, 8, but positive or negative, 16 possible. Then to find your actual, that's when you have to use those factors, and you're going to use synthetic division in order to try and solve. So if you're going to use synthetic division to solve, you can really start wherever you want to start. So if you want to start with, your 1, if you want to start with your 2s, if you want to start with your 3s, it doesn't matter which ones you want to start with. Always start with the easiest though. So I'm going to start, I'm going to try a 1. Remember, you're going to take all your coefficients, 5, -2, 20, -8. 5, multiply on the outside, add on the inside. Multiply on the outside, add on the inside. This one doesn't work because you need to get 0. So then maybe you're like, okay, the next easiest one is 2. Maybe you like positive numbers. 5, -2, 20, -8. 5, 10, 8, 16, 36, and then, was that like 72? That one obviously does not work. Then you're going to keep trying. So you're going to try just number after number after number until you find one that's going to work. I know that one of them that does end up working is 2/5, so I'm going to go ahead and show you 2/5. So 5, -2, 20, -8. This is going to give me 2, 0, 0. This is going to give me 20. 20 is going to give me 8. That gives me a 0. That means that this checks. So that's really what you're looking for, is to see if you can get something that works out. Now, this is equal to 5x squared plus 20. This is one that at this point, you can set this equal to 0 and you can solve for your last two. If you were left with a trinomial, then you'd have to use like the quadratic formula. But here we can subtract 20, subtract 20. Am I still on the screen? Getting close. 5x squared is equal to -20. Divide by 4, divide by 4. I'm going to come up here to finish. So I'm going to get that x squared is equal to -5. Square root of that is going to give you that x is equal to plus or minus I root 5. This is one of your roots. This is one of your, or this is two of your roots. This is one of your roots. So you end up kind of hitting everything. All right, same thing happens on the next one. So if you wanted to do the next one, you're doing P over Q. That's all your factors of 7 over all your factors of 2. So that's going to be plus or minus 7, plus or minus 1 over plus or minus 1, plus or minus 2. So your possible combinations here end up being plus or minus 7, plus or minus 1, plus or minus 7 halves, plus or minus 1/2. And then again, just go ahead and you start trying. If I plug in 1, now, big thing, we're missing our x cubed here. We're missing that. We're missing our x here. So when you do synthetic division, it's going to be 2, 0, -9, 0, 7. You have to put in placeholders for all those. So this is 4, 3, 2, 1, nothing. All right, then you can try. 2, 2. This ends up giving you a -7, -7, -7. And then this ends up giving you a -7. Look at that. That one works. Woohoo! Once you do that, then you can go through. Now, step 1, unless it tells you to do rational root theorem, should always be to factor. Both of these are factorable. That's what you would have done as your step 1. But if they're not factorable, that's when you go ahead and use rational root theorem. So now I can rewrite this. This is 2x cubed plus 2x squared plus, not plus, minus 7x minus 7. This is factorable. I can factor out a 2x squared and I'm left with x plus 1. I can factor out a -7 and I'm left with x plus 1. 2x squared minus 7, x plus 1. So far, positive 1 is one of your factors. This is going to make it that -1 is one of your factors. And then we have to have 4 zeros or roots all together because this is degree 4. So if we set this equal to 0, you end up getting x squared is equal to add 7 divided by 2, 7 halves. And then you take the square root. X is equal to plus or minus the square root of 7 halves. So all your zeros, x equals 1, -1, the square root of 7 over 2, the negative square root of 7 over 2. Did I make all that? I'm assuming it's going to ask you possible. It might ask you to find one in particular, but I'm assuming it'll more ask for the possible ones. All right, tune in for that next video if you need help with the next one.